Okay, I'm talk quietly and I'm trying to kind of zero in on using the bamboo with Smooth Draw 3.2.6 because that's what Sal does. And I'm going to go back here and I'm going to add a new layer so I can do some of this kind of layering and be able to push different things out for different imports into other programs. And you'll notice here that you've got a lot of potential of tools which you don't see across the top here, but all that sense of using colors is a big thing. So I'm going to go ahead now and try to lay in just a really basic concept, a basic formula of deflection. And I'm going to, for that reason, I'm going to go ahead and draw my supports in green, draw my ground, if you would, in orange. I'll draw my beam in blue, and I'll then draw my text in red. So I have something here with a span of L and a weight, a constant weight down. That's a great constant, right? Of W, where W is force over length, and L is length, which of course is distance. Force is going to be pounds or newtons. And we're going to want to determine the maximum moment in the beam, which is going to occur, which occurs at, and I'm going to try a little bit of erase here now. Erase that a little bit there. That's not so good. How's that eraser? That eraser's a little bit better. Which occurs at L over 2. And again, we know that from this concept of a hanging cable with reactions there and there, with that being equal to inch into T, we know that WL squared over 8 equals T times the sag, and we remember that as being our basic calculation for maximum moment. So we know the maximum moment is equal to WL squared over 8, and we know that my maximum deflection equals 5 WL to the 4th power over 384 EI. Now we want to also then add to that perhaps another force, a spot force, that's equal to big W, which is the same as WL. So we've added basically the doubling of the WL here again, and now the maximum is going to be the same, plus, remember when we put something in the middle, it's going to be twice as bad, so that's going to be WL squared over 4. WL squared over 4. And realistically, it's also going to cause a greater deflection here as well. So what I'm going to do right now is I'm going to add another layer or two. Now as I draft on here, you can realize I can start to turn these on and off, as the case would be, background layer. And we have something there that cannot be edited, so I'm going to take this right now and do export the current layer. So I'm going to see if that one turns off. That's not the one I want. That layer here, I can now say export layer image, put it someplace I know where it's at, right on the top of that. we get to that point of now being able to do the kind of the idea of the glass wall. So I'm going to go ahead and get rid of that. That's again sketch smooth draw. Bring up SketchUp one more time. This time we'll see if I can find a file that's out there. I won't necessarily. I'm going to just go ahead and okay. I'll go ahead and do File, Import. If you now remember that is an image, we can bring it in eventually as a texture. Bring in that image. And what we can finally then do with that image, if we think about it, we'll get the concept here in this program. Remember, of course, it's very good and important to have a little box that you can go to so that you can grab something here, go to the rotate, hold the shift key, which I can't do because of the, right? I'll test that up this way. Now you have this concept of a board that you can perhaps see through. And so if you set your camera up here, I'm going to set my camera, me looking up at the screen, right? Get that concept of, and I can change my eye height, go here, that concept of being able to look around. And being able to see through, basically. So if you remember back whenever, in the Intel commercials, get that concept that you have really what's a blackboard that's kind of virtually something you can kind of write in the air on. So some great value when you start doing stuff like that, especially when you start having motion controllers, motion capture to kind of sketch out in space where maybe your dance movements would be, or whatever, as you look at moving animation through here, that you can put your trails, if you would. Though you'd see it's a little bit more difficult than to push this into 3D, but we can go ahead and just try that a little bit here before we finish out. So we can now do it again. We can do File and Import, and this time we'll bring in that picture as an image, and we can find that it's going to tend to learn, it'll cast itself to a particular plane, which we now can scale it up per se. Hit the scale button here, pull that up. And then we can get this idea how quickly, as I deselect, you can get to this concept of 3D flat spaces, one space upon another, and how you can really combine some of the tools of your raster tools. That was just something that was kind of using all the paint tools and all that right there. How you can combine your raster tools, I'll look through that. I have no idea what's going on there. With SketchUp to get some pretty incredible stuff out of it. So we'll leave it at that. I'll go ahead and put this one out. I'm going to go ahead once again, close the SketchUp up, not save that per se, and start to realize how much value there is in combining something like Smooth Draw or Photoshop or whatever with, in fact, something like MeshLab or SketchUp or PacificT.com's mathematical program. Thanks for listening.